cow. They usually call this like a cow, right? Um,
Wait, why is it called a cow? I've never heard that. Yeah.
give me your daylight savings takes.
Okay. I don't know if this is apocryphal, but apparently in the 20s, we already tried this. We sent, we were like daylight savings all year round. And it lasted a year, and everyone hated it. So you got to
Right.
make of that what you think. But apparently, we've already like tried this experiment.
I'm reading the history of daylight savings right now.
Okay. Let's put the browser on
Most
the screen.
jurisdictions abandoned DST in the years after the war ended in 1918, with the exception of Canada, the UK, France, Ireland, and the US. Became common during World War II and was widely adopted in America and Europe from the 1970s as a result of the 1970s energy crisis. What energy crisis is that? 'Cause you just wanted to align your
At what
business
point
time
are
with.
we not in an energy crisis? I feel like that's why we have constant war.
I mean, in the 70s, that was the whole like you were lining up for a day to get gas kind of thing. Gas prices were really high. Yeah, that was bad.
So let me see. I'm trying to find the year-round daylight savings time too. Oh yeah, sorry. It was the 70s. In 1971, year-round
Okay.
daylight savings time in the United States or United Kingdom.
Well, I mean,
It's
that's
a,
a useful piece of context,
yeah,
right?
at the very bottom of this, there's perceived problems with permanent daylight time.
Okay. Uh, Complaints of children going to school in the dark and working people commuting and starting their day in pitch darkness during the winter months. This is this is in the U.S.
The first part is. Second part
This is
is.
following the enactment.
Yeah, so it's wild to me that we already tried this, and historically somehow no one has brought this up. So I don't know. Maybe we needed Twitter back then to convince people that it was
The
okay.
thing with Russia and the UK is they're really high
Yeah.
up there, latitude wise. So I don't believe anything they say.
Well, fair enough. Yeah,
Um,
that's my counter. My counterpoint is that somehow the U.S. already sort of tried it on for size once, but then as we are
we forgot about
reached
it.
no consensus and gave up like the first time.
Yeah, we had a pandemic a while ago as well.
Yep. But like no one from that is still alive to remember it, probably.
It's true.
But
It's
like
true.
but like this is like our parents should remember this.
Okay. Yeah. So not only is history doomed to repeat itself, it's doomed to repeat itself like
Quite quickly.
very quickly. Good Lord.
Yeah, we'll see. We'll see. Well, I hope you're having an excellent week of not working. That's pretty exciting.
Yes, and I'm back from my trip,
Oh, how was it?
which
Yeah.
was fantastic. Yeah, we went up to Sea Ranch, which is just some. It's a town basically between Bodega Bay and Humboldt County, not Mendocino County. It's actually right at the border between Sonoma and Mendocino. I'm saying that out loud as if it means anything to anybody.
Someone could pull up a map while they're watching us stream, and
It's true. It is very true. And Sea Ranch was this like experimental housing development in the 1960s.
I love that shit.
Yeah. That was it was basically kind of like 1960s like intellectual commune fad kind of thing.
Oh, interesting.
Because it was like a bunch of like Berkeley designers that went up there and they're like, we're gonna make our utopia on the Northern California coast.
That's cool.
And they had all these high-minded ideals about it being kind of like a rejection of the modern capitalist culture. But then they were like,
How'd that go for
oh
them?
wait, who's going to serve us in this utopia.
Ah, Berkeley. Yes,
And then
indeed.
secondarily, they were like, oh, and then also I want to keep my housing prices really high. So one morning we were just kind of sitting around reading like they have like basically like a town-wide HOA that like mandates exactly how you have to build your buildings. And it's very, very strict.
Wow, that's like everything that's always wrong with HOAs from what I've been told. So great job, Berkeley. You really brought that forward to the experimental edge.
Yeah. It struck me as like very classically it's like liberal thinking to the point that it knows how to reject liberalism in the superficial ways, you know?
Yep. Oh, that's funny.
Which is like that coffee shop we were talking about, right? That coffee company in the Midwest. Same thing. They classify themselves as like super progressive, but that only lasts as long as they can do the easy things, right?
Gosh, yeah. Unions are great, but maybe not for us. We can just talk
Maybe
it
not.
out.
Yeah, but we don't need a union. I just don't think it's the right thing for this company. Yeah.
Yep. The forever refrain.
Yep.
Well.
Should we talk about the game? We haven't talked about the game in a little while.
I mean,
it's been like a week.
Let me pull the screen back up.
Yeah.
What? Yeah. What's the game do?
Did I break the particle toy?
Did you know?
Or did I add a time to live on the particles? It's gonna take a little while, but you'll see them gradually disappear over time.
Now, are you streaming at like 1 frame per second, or are the particles really slow?
I think the particles are slow.
Okay.
But allow me to, check my zoom settings.
No, I can. The rest of your UI is moving really well. Them particles, though. Are they still Are they still spinning?
They're still spinning. Maybe there's just too much going on. What if I reduce the number of particles?
As I say, you've crushed the video codec. Oh, but I do. Oh, that's really interesting. Yeah, as they were disappearing, it was actually doing a lot better. Oh, that's great. That's awesome. Cool.
It takes them a while. I think the time it's a random time between 5 and 15 seconds. That's for TTL.
Ah, that's sick. Boy, let me just put it out there. When there are like 3 particles on the screen, your video is crystal clear.
When you just lower your standards in life, you find yourself just much happier. I think that's not a completely fallacious way to go about your life.
No, I mean, expecting perfection is definitely a disappointing way to go.
Yeah, I you know what? Maybe Buddhism is a more high-minded way of approaching it than the way that I said, but it's more or less similar, right? It's just like without any desires, but if you don't actually want anything, it turns out that life is pretty good, or at least life is endurable.
It turns out. I feel like the counter argument is that people who say money can't buy you happiness have never actually needed money.
That is true.
But if we didn't need money,
actually, I think that was Nietzsche's whole hypothesis, right? Like a lot of our morality, that we hold to in the modern world is essentially derived from a morality that we either invented to endure our lives as serfs, or morality that was handed down to us in order to control us, right?
Yep.
So, contra the Buddhists, we should want things. We should want power. We should want nice things, right? And we should take them from the rich people.
Now you're talking.
Yeah.
Yeah. Did you see any of the Amazon drama today?
I saw tweets about them denying that people peed into bottles. That was pretty much my limit. I know when is the vote? It's in 4 days, right? The one in Alabama.
I think so. It was yeah, they vehemently denied that anyone has peed into a bottle while working for Amazon. And then the very next day someone released a bunch of internal Amazon documents about how peeing in bottles is making the vehicles like a hygiene hazard. And they were like,
And this is like an internal memo.
it was like an internal memo. Yeah. Yeah, they're like, people are pooping in the trucks and peeing in bottles, and this isn't good. Says Amazon internal memo.
Yeah. Amazon News? Who the fuck is Amazon
Who
News?
the fuck do you think it is? This is the
Official
propaganda
account for
account.
news.
Yeah.
Oh, yeah. Is this Jay Carney? This guy,
Oh no, is it?
former White House press secretary. This dweeb. Look at him.
Does he work for Amazon?
He works for Amazon
Oh
now. Yes, he
no.
went straight from Obama to Amazon, which is I think actually a fairly predictable trajectory, right?
That's legit. Yeah.
Yeah,
Oof.
it's been chugging away.
Woof.
Yeah, it's probably got a lot of that sweet pandemic equity.
Oh my god, fucking Amazon people. Ugh.
Yeah.
Ugh.
All right, enough about those assholes.
Yeah.
Let's talk about particles.
Give us
All
the
right.
particles.
So in order to do time to live,
Yeah.
I added a new thing to the shader. There is this new shader property or attribute. I'm going to put it first because it's better. Better in first position. And what it does is if it is 0, I learned today as I was messing with this that your attributes can only be floats or vectors of floats. You can't do attributes that are like byte arrays and stuff.
Maybe floats or vectors of float. Oh, interesting. Okay.
That's just
That's just
OpenGL.
Yeah, it's the gift we've been given by the. Okay. Cool.
Even though the API is like so painstaking about letting you define like byte arrays and that kind of thing, but
Yeah, but not this time.
not for shaders, for other things.
All right.
So all it does is like if this flag is set to 0, it sets the position of the vertex to 2.0, 2.0, 2.0, 1.0.
Okay.
Now, if you recall, the point of our projection matrix is to basically move things from their world position into clip space, which is essentially not a. Do we call it a unit cube? I don't know. A unit cube to me is like one. It has like a distance of 1 on every edge.
Yeah, but our
This
clip
is the
space
double
is
unit
actually
cube.
our clip space is -1 to 1, right?
Exactly. It's
Yeah.
like the double unit cube. And anything that sits outside of that double unit cube is clipped and is not. It's not rasterized, and then it's not, and the attributes are not interpolated and sent to the fragment shader. So basically, what this is saying is that if if the value of this particular property is 0, then we will go ahead and put the position of the vertex. We'll force it to outside of clip space, and then early out. So
Sick.
it essentially turns the vertex off, right?
That's cool. So it skips all our matrix multiplication and immediately like this takes up less computation sort of overall in the GPU, and you're just saying this in as a boolean, as a float boolean. Interesting. Okay, I like it.
Yeah.
And
it's a boolean.
And as I say, this is because we can't. Deleting stuff is a hard problem, right? Like we are going to have trouble like deciding that we want to. Like if we delete particle 1 because it runs out of lifespan, like we still have that spot in our array of data that we're sending to the GPU, so that becomes really hard to manage, right?
Yeah, you hit the nail on the head.
Cool.
Like we spent so much time making our particle system like a bunch of arrays of things. This has been refactored a little bit since we were last on stream, but I sent you the commit that originally did some of this refactoring. Yeah, I think you're exactly right. Basically, we have an array of 30,000 or however many particles we want to render in the entire system, and they're going to all have different time to lives. And what we're probably just going to do is just render everything, right? Or at least render as much into our list of particles as we have active particles. So I basically added an active flag in the shader that does exactly what you said. If I want to actually be able to turn off a particular particle, this is how we do it.
Cool. All right. Yeah.
Currently, the way that this works is that when we do the render, we will actually simulate every single particle. And if the active value for a particular particle is 0, we won't simulate it. And then we do a time to live processing. So we'll actually take the current time to live of the current particle. We'll subtract off the delta time. Mm-hmm. If the delta time has gone to be 0 or less than 0, then we basically free up that particle.
Cool. Now, I have a curiosity, which is that if you comment out lines 146 to 154, do we get any performance back, or is the video codec what's actually squashing the triangles down? Because I feel like we were getting more on the stream earlier when we weren't doing this computation. So now I'm wondering what's going on. And it makes sense if it's an update.
We're doing this computation?
Yeah, is it possible that something is slow there? Am I crazy?
Well, it's smooth on my side.
It's smooth on your side. Never mind. Sorry.
Okay. Yeah. Oh, yeah. Sorry. I think you had asked me that, and I just didn't answer it directly.
Yeah.
I get 60 FPS.
Perfect.
Let me try to prove it to you. I think we got up to 100K last time. I'm not sure if it'll still sustain that, but let's try it.
Yeah, but if you were seeing it, that's great. It was really interesting. It's interesting to me that it got worse on this side. Oh, that's a nice way to write that. Yeah.
Okay. I actually don't know how to.
I can barely even. Oh God. It took like a hot second to even get the entire gray screen to render. That's so funny.
Yeah, is this going to tell me my FPS?
Oh wow, hovering over that looked really cool. Huh, I love it.
I'm actually FPS. Yeah, FPS. Can I expand this?
I mean that looks like a crisp old 60.
It looks like a solid 60, right?
Yeah, it sure does.
Too bad I can't make it taller to actually see what it is.
Nah,
what's the point of this graph if I can't? Come on, guys. You're killing me here. Well, I think you believe me, right?
I absolutely believe you now. Thank you for proving that, because I was like sort of racking my brain. I was like, what did we change? But that makes a lot of sense.
I think it might be my zoom settings, man. How do I change my zoom settings? Where's zoom?
I'm not sure we can change. Let's see.
Zoom preferences.
Uh-huh.
Video.
Probably under share screen, maybe. Let's see. What's in advanced? That's always what I want to know. Oh, it's at the bottom of share screen.
At the bottom, yes. Use TCP connection for screen sharing. I guess it's using UDP right now.
That's cool.
Cool. I can limit my screen share to 10 frames per second. Can I limit it to 60? Is that possible? No. Alas.
I'm actually curious what would happen if you tried limiting it to 15. Because I wonder if it'll actually do a little less work to get those frames to me, if it's not trying to like make it happen super fast. It's a silly hypothesis, but
all right. Well, let's see what it looks like.
Yeah.
Is that better? Or
it's
worse?
Actually a little better. Yeah.
No kidding. So I'm coming. Right now, I'm 15 FPS to you, and then therefore at most 15 FPS to the stream.
That's correct. Yeah, that actually was a little better.
Okay. Well, we'll try it right now.
Yeah.
Let me know how everything else looks. Like
when
I'm typing and stuff.
It's fine. 15 is actually like. Turns out 15 for this is not unreasonable.
Okay.
Yeah, looks good to me.
I'm puzzled, but I'm not gonna debate Zoom. Not right now.
We all lose that debate together.
Okay,
sweet.
There's gotta be like a premium
Somewhere.
video chat service somewhere, right?
I'd say someone's got the good Zoom.
Super premium video chat service.
I mean, it wasn't even Tuple, and we paid for that.
Yeah, kind of wasn't. Well, Tuple was like a CPU hog. We could try it again, although we kind of need a Windows client, don't we?
We need a little something for that, yeah.
Yeah. Discord was okay, but it was also kind of a hog as well. Right?
Discord was a little hoggy, yeah.
Okay. Premium.chat. No, that's not fine. Somehow I think that searching for super premium video chat service wasn't going to get me what I wanted.
That's so weird. I don't know why that's the case. I thought you cracked it.
I want the Mercedes of video chat services. I think that Zoom is like the Honda Civic of video chat services.
It's a lot like the Honda Civic. It's maybe an old Honda Civic too.
Right. Speaking of which, I think I'm probably gonna get the Civic.
Nice, hell yeah.
That's the way it's gonna go.
Big fan of Civic. You gonna get that manual transmission?
No. I learned how to drive stick in my mid-20s, but I never really did it. I kind of just like learned for fun. And it wasn't that fun. So
that's fair. Okay, I think it's fun.
Sorry to disappoint.
It's
I don't really drive very much, so maybe that's a
great part.
Is that a reason to do manual?
I'm not sure there's any reason to do a manual transmission, to be honest. Like, the only reason is to feel smug about having a manual transmission, which I do, or I did when I had one.
All the new cars, they have something called continuously variable transmission.
Oh, that's pretty cool. So no gears.
I don't think it actually uses gears. It uses some kind of like liquid system, or I'm not even going to embarrass myself to like try to explain what a CVT does, but
all right, but that's pretty sick.
Yeah, and I think the first car that I ever was aware of that had that technology was the Prius. But I think there's like a non-zero amount of money being spent on any new car to simulate gear transitions on a CVT.
Oh, come on, really?
So like the Civic that I drove today, like it has paddle shifters on the wheel.
Why?
And all it does is stutter the acceleration, so it makes you feel like you're changing gears.
No shit. That's hilarious.
It's embarrassing, yeah.
That is a little embarrassing.
It's embarrassing.
Okay, wow, we are just monkeys in boxes who really need to be told that the gears are shifting. That's annoying.
Well, I guess that being said, like, I don't know how close to drive-by-wire our cars are nowadays, but they're pretty fucking close, right? And I think there's probably a lot about the way we operate a car right now that is meant to, I think, appeal to our sense of how things used to work.
Right. Yeah, because like the car is doing a lot. Like the car is steering for you, and you just have to trust that that's actually happening when you like nudge the wheel slightly, among other things. Yep.
Yeah.
That's fair.
Yeah. So Zoom being the Honda Civic of chat services, it is reliable. It is what everybody buys. Maybe not the best performing.
No.
But it might be the best performing. It literally might. That's why we're still using it, right?
It might not be the worst performing, which is honestly a little scary. Yeah.
Yeah. Well, I mean, like Hangouts is worse than this, right? I think Skype is worse than this.
I think I don't know if this was real. No, this was a parody. It was the CEO of Skype just being like, "How could you forget about us this year?" But it's probably because it was terrible.
Yeah.
There's a reason I haven't touched Skype at all in the pandemic.
So onto particle emitters.
Yeah, we'll get there. We'll get there eventually. So what's next? Is it like to actually emit them?
Yeah. So I think you and I were talking a little bit about like what is the responsibility of this particle system as opposed to potentially other things.
That's right.
And my response to that question is I don't really know. The particle system is relatively low level in that it contains all the data for every single particle that we eventually send off to the GPU. Right? We've got this new active thing which is that flag, right? That I showed you in the shader.
Yep.
And it's got the rotations, translations, scales, and colors, which we're familiar with. But it's also responsible for doing a little bit of simulation on the particle. So what I would call physics and also liveness tracking. So it has a TTL now. I just added that. It always had this rotational velocity notion.
Yep.
So you could imagine us doing even more, adding something like a linear acceleration or linear velocity. And what's even neater is a linear acceleration that doesn't point in the same direction as the initial velocity. So you could do things like ballistics and that kind of thing.
Oh.
So you could have gravity or whatever.
That's cool.
Yeah. There's also color animation, all kinds of arbitrary like simulation that we could add on to this. And then you could also have the meta side of things, which is like what creates the particles and what sets their initial properties. Right. So right now, the way that this works is that anything that like directly contributes to manipulating the fundamental attributes is kind of in the particle system itself. But the framing that I have in my mind, which is not necessarily the framing that we need to have going forward, is that we have one particle system for the entire game.
Right.
Or at least one particle system for the entire family of particles that use the same shader with the same attributes, right? We could have a particle shader that maybe took different attributes, right? They could be very specialized to a particular particle effect. It could take textures, like if you wanted to texture our particles.
Oh, interesting.
We could make our particles quads, right? But this particle system is very much like attached to a particular structure of a shader, right? Of a specific shader.
Yeah. Gosh, that's really interesting.
Yeah. And then also anything that directly contributes to these values is also being stored in the particle system, although that's not necessarily what we have to do, right? Another model of this is you could imagine having different particle emitter classes that are responsible for manipulating these values or at least sections of these arrays. Each emitter gets a chunk of these arrays to manipulate as they see fit, right?
That's kind of what I was thinking. Yeah, I was wondering if we could have, if as you instantiate emitters, you just got assigned a memory block, wrote to it, and then that actually works with the array views you were talking about.
Okay. Oh yeah. I didn't even think about that, but you're right.
Oh, I thought that's where you're going to build up to.
No, I'm not building up anywhere really. I'm just kind of talking out of my ass. Nothing new. I don't really have a plan. And then I think there's still a question of if you have a emitter class, do those emitter classes actually contain any state, or do they contain are they parameterized in any way? The idea that I originally had. Okay, so I was going somewhere, but it's not necessarily a destination I want to take us. It was just the way that I thought this might work.
Okay.
Is that we have an emitter class, and the emitter is basically just responsible for calling it this function, add, which basically generates new particles. But once the particle is created, the emitter no longer has control of that particle. It just created it with particular configuration, and then it just told the system like, hey, simulate.
That's interesting. Okay, so it adds a particle with whatever attributes we could possibly want. And then yeah, the update function just has to handle all of that.
Yeah.
That's
But
cool.
the kind of like all the whole universe of simulation
Hmm?
is within the particle system. So the particle system, it has everything you need inside of it to stimulate every possible particle that you could generate. It's just that like the logic that creates new particles sits outside of the particle system.
That's really interesting because I was as you were describing that, I was thinking of a similar system, but actually where an emitter registers with the system for, I'm going to simulate max 100 particles, so give me a chunk of memory. And then we actually just call update into that. So whatever ends up in that chunk of memory is what the particle system renders. That's not much of a system, is it? That sort of hands a lot of the system duties off to another class. So
I think that that might be okay. Um,
I can go either way on
yeah.
that. They both seem pretty workable with thought. So
Okay. Um, Now, one thing that I can't do right now is animate a particle forever. Like, there's no way to do a TTL, an infinite TTL. And the reason for that is that I didn't know how to like deallocate a particle, right? Like something outside the particle system would need to know. I guess one thing I could do is just return the index here, right? I could return the index and make free a public function.
oh yeah, I see.
Right.
Okay, I guess I haven't seen this since FreeList showed up, right? I didn't quite grok that, but we're actually tracking where a particle, what index was destroyed to reallocate at the first free index, if there is one. Okay.
Yeah, I had this Galaxy Brain idea. I made it a priority queue at first because I had this Galaxy Brain idea of wanting to keep all of our particles towards the fronts of all of these arrays, so that when we actually rendered things, we could pass it
The minimal
a
number
number
possible.
of
Yeah.
like the furthest particle in our array that we could possibly draw.
Yeah, because if there's nothing on the screen, the system could do. Well, the GPU could do nothing, which would be great.
Yeah, because ultimately this number gets passed down to the draw call, right?
Yep.
And you'd basically take pressure off the GPU if you could do that. But I ran into two obstacles. One of them, the more compelling one, is just technical, and or like in terms of like how hard it is to determine that number. And then the second one is a little bit more theoretical, which is that like if you want your particle to be prepared to render in worst case, maybe you should just render the worst case all the time. You know?
Right. I was gonna say, yeah, if we're not looping through this on every step, we actually just won't. We won't know, or we'll have like unbound performance issues that come up when things get exciting, which honestly is a thing I see in games all the time. So maybe that's how they do it.
Yeah. Yeah, so they're probably trying to tell each system to use the minimum number of resources based on what it needs to draw, right? Which is not what this is doing. This is saying, I'm gonna just like attempt to draw every single particle that I've allocated capacity for, and it's not until we actually get to the shader
That we start
that
cutting
we
stuff
cut
out,
something off. Yeah.
which still has quite the performance impact, I'm sure.
It's definitely possible. Yeah, I mean, obviously the draw call in render particles, right? We have the instances, and that just gets again passed to the draw call. The lower this number, probably the faster it's going to perform. So, if sort of planning for worst case and always doing worst case is not a valid philosophy, which I'm totally down for, we're left with the challenge of figuring out what that number is supposed to be.
Yep.
So we could set a high watermark, right? Like let's say like as you add stuff, you can increment a number, right? That says like this is the highest index of a particle that's been added. But the problem is the TTLs are all different, right? We could potentially sort the particle data by highest TTL, but that would involve shuffling data around all of these arrays.
Oh,
Right?
that sounds nightmarish. Yeah.
It sounds pretty rough, right? So what we'd need instead is something that said, okay, when we free particle 10, and it's the end of the list, let's say, or particle 10 is our high watermark, what do we update the high watermark to? And it's got to be like the next highest particle that hasn't died yet, right?
Gotcha.
Yeah, sorry, go ahead.
Do we not free ourselves on TTL? We do, right?
Yeah, when we reach when the TTL basically, when we simulate the particle,
Oh, nice.
and the TTL is exhausted, we free the particle,
Okay.
right? And freeing the particle, as you can see, is actually super minimal. It doesn't modify anything. All it does, it actually just modifies the one attribute. It says, hey, shader, don't draw this when it gets to you. And then it adds whatever we just got, into. I made it a priority queue again because, like, I thought, like, what the priority queue is going to do is it's going to give you the leftmost element that you can possibly take, right?
No, that part seems really good.
Yeah. The other thing we could do is just make it an array, right, and just like shift off the front of it or pop off the back of it, right?
Yeah. Yeah, I guess so. It's interesting. I'm trying to think of like in a system where, yeah, if we're trying to keep it full and send the smallest byte array we can to the GPU. I guess I'm trying to think like what the behavior of particle emitter would be, where it like spits 1,000 things onto the screen and they're all dead within a second, or 2 seconds, and then we have sort of like a gap of 1,000 or like a new, yeah.
Okay, so if we wanted to keep that high watermark accurate, I think we need a data structure that provides these two things, which for a simplistic data structure, I don't think this exists in the vocabulary of like simple data structures. We do have something that says give me the highest value, and that is our priority queue, actually. Yep. What we don't have is a priority queue that also says I want to remove an arbitrary value out of that. And if you just used a priority queue and didn't have any supplementary indexes for the priority queue, finding an arbitrary value inside a heap is not fast, I think. Yeah. The underlying heap data structure kind of goes like this. Let's say a priority queue ranks smaller numbers the highest, right? So you'd have like the value 0 is going to be at the top. And then you'd have the value 1 and 2. And 1 and 2 are the children of 0, right? And then you could have 3 and 4, and 3 and 4 are both the children of 1. But like you could theoretically have like 5 and 4 and 7 and 3, because 7 and 3 are the children of 2, right? 5 and 4 belong to 1, and 2 is the parent of 7 and 3. So if we just like, let's say like our high watermark was 7, and this particle died. Is it sufficient to just shift everything else up in the array? I don't know if that. I don't know if that is very good. But what we could do is we could. Well, first of all, how did you find 7, right? Because let's say you know that particle 7 just died. And this one you know because the simulation told you, right? We actually literally iterated over every particle in the simulation, right? And so first of all, how do you find particle 7, right? You could just linear search the entire array, right? But when that array is like 100,000 elements long, it's kind of shitty. I mean, we are iterating over 100,000 things here, so it's just like, let's do it again. Every time.
I was just saying,
but you don't want to do it every time you free,
once,
right?
yeah. It's nice that we have a just linear scale.
Yeah.
Huh.
So what you could do is you could have an index, maintain an index that maps values to positions in the heap. So you'd know that, like, I'm just going to put the positions above this, right? This is going to be a little bit, let's just say it's position A, position B, position C, position D, position E, F, G. You'd know that, like, 7 is mapped to F, right? Oh, sorry.
Yep.
So you would go immediately to slot F, you delete 7. And then you would do a standard heap operation where you took the last thing off the array, stuck it in this place, and made sure that this thing was in the right position, right? But note that every time if I move value 3 from position G to position F, I have to update this index too, because right. So anytime you insert into this priority queue, every motion you make, there needs to be a corresponding update to the index, right? And the priority queue, as you recall, does a lot of motions, right? We do this swapping in a loop.
Oh, right. Yeah.
So anytime we do this, that's going to update the index. And then also in this loop here, we've got to do the same thing over here. Maybe that's all fine. I don't know.
Gosh. Okay.
So just the girth of the problem kind of is that apparent?
It is.
Okay.
Yeah, I wonder. I guess I'm just wondering how much we should attempt to optimize with this versus
just draw everything, right? So that's actually basically what I opted for. It's just like versus just draw everything,
just eat it. Yeah.
Yeah. I would be curious to know how adding something like this to our priority queue data structure would affect things, right? Because in principle, you're not necessarily like adding popping and pushing into your priority queue that frequently.
Yep.
At least in terms of one that is doing the particle system. Just that once when you create a new particle, once when it dies, right? And maybe that's not too bad.
Yeah.
I'm almost more worried about the code complexity than I am the performance at this point.
It sounds hard to reason about. I guess the emitter system itself could track sort of. It would not be optimal, but it could at least track like what the capacity is and when it sees exactly that capacity particle die and like decrement that.
I see what you're saying.
Because eventually every emitter should die, and there's probably a state where there's 0 emitters emitting on the screen at some point, and we could actually clear all the way back down to 0 just by virtue of particles having fallen off.
I see. So you're basically saying if our high watermark particle dies, search backwards from that high watermark for the next active particle, and that's the new high watermark.
Oh, right, because the one before it could have died. Yeah, basically.
Yeah. Well, we can try that.
Yeah, it's like not optimally performant in either direction, but
okay. What is the name? What's a good word for high watermark?
I mean, I was gonna say it's kind of capacity is what we've actually allocated.
It's like the render boundary. Let's just call it the high watermark.
Yeah.
Too many characters. I didn't like it because it was like a lot of characters, but I think it makes the most sense out of any word that I would try to pick, right? Okay, so the high watermark starts off at 0.
Yep.
And when we add something, if the index is greater than the current high watermark, then the high watermark is the index, right?
Yep.
All right, so that's there. And then when we free it, if n is the high watermark, then what we need to do is search backwards. At greater than or equal to 0, right?
Yep.
And then we say if this dot active dot get of I is equal to 1, this dot high watermark equals I, break.
That ain't bad, actually. It's a little more work on free, but...
And then we draw this dot high watermark,
Yep.
right?
I think it already re-rendered. Yeah. Cool. Are they dying? Yeah, they're dying.
I mean, they're going to die regardless, right? So the real question is, like, if we implemented this incorrectly, we could spawn particles. I mean, this example is not a good one because we're not spawning particles live, right? All the particles are spawned once.
Yeah, it should go back down to 0. Oh, hey, Dean's in the chat. What's up, babies? What's up, Dean?
Hey, Dean. It's been a little while.
Yeah, we're just making
Welcome back.
We took a break too. Everyone took a break.
Yeah.
We're making these particles particle.
So if we implemented this incorrectly, what would happen is when we added new particles,
they would not.
They'd be added like on the other side of the high watermark, and they wouldn't get rendered.
Exactly.
Right?
Yeah, we'd have particles that. Yeah, but I feel like the addition.
I feel like the logic is relatively simple though, right?
And the addition side, I'm like extra comfortable with. I feel like when you add a particle, it's definitely like, yeah, lines 130 to 132. I feel like are hard to mess up for that respect. So like, I'd be more worried about the free not freeing enough, and that's actually that's fine. I can live with that.
Yeah. Boy, this looks. This kind of like cow. They usually call this like a cow, right?
Wait, why is it called a cow? I've never heard that. Yes. Yes.
I might be smoking crack.
Wait, sorry. I just really love that there was an indentation on a cow.
Oh.
Ew.
Okay.
Wait, oh, your search results. Oh my god.
Does a cap come out of a cow's bum?
Wow. Okay. Sure. I mean,
this is and it's bum, right? So these are Commonwealth people,
British farmers
British
only.
people,
Yeah.
the English in particular, right? Somehow Node.js callback hell looks like a cow.
Okay. Hit the must include cow button. That's what I want. Okay, I see some cows. Yeah.
No. You know what? I think I must have read the one article like that said. Basically, they said that like you'd see a bunch of these and they look like cows.
I'm into it.
All right.
Yeah, none of that cow.
So it's not a cow, but this looks funny to me.
It looks funny. Yeah, I agree.
But the alternative is to do this. And this is okay.
This is where I really want the Ruby postfix.
Oh, like return if
Yeah,
this. Yeah.
it's one of the language's best features.
Yeah. But if we wanted to go really insane about indentation saving, we do, the same thing down here. But,
Yep. But you've uncounted. You've done one fewer cows. So the herd got smaller. I'm into it.
I'm going to leave it the way it was.
Okay.
Here's my rationale. I think this code in here is short enough that indenting the whole thing is okay. If it was getting much longer, then I would probably start to think that the indentation was too much. But this has the nice advantage of saying that, like, okay, the if statement is about the high watermark, and so therefore it stands to reason that all the code in here is about the high watermark, something like that.
Yep. I feel good about that. It looks fine. Nice.
High watermark is.
Heck yeah. So I'm curious because we sure
This looks amazing on my end, by the way.
It's-
you just have no idea what you're missing.
it's looking pretty good, and I'm checking out the stream too, and it's coming through. It's coming through good. If it was 60 FPS, I know it would just be mind blowing.
I can't get enough. I'm addicted to it.
I'm with you. Yeah.
This is just infinite jest right here. We can't stop watching. We're just gonna starve.
Oh goodness.
Okay.
Eventually the particles themselves starve. I was thinking it'd be cool if they shrank as they TTL'd. That's what I thought was happening originally as the universe sort of collapsed on itself there. So I have a thought.
Yes.
We've made our particle star field, but like it'd be really cool to have to like put an actual emitter in here and have them coming from a source and maybe like continually spawning. Is it time?
I like that idea. Yeah. So we want to have a notion of an emitter, right?
Yeah, and I think let's take the first approach and say the emitter calls add. The emitter calls add. That's it.
Yep.
Are you gonna run the emitter like sort of as a class in here for a second, and then we'll export it later? Yeah.
Yeah. So interface.
We could just write it, and then the interface will sort of come out of us figuring it out.
Yeah. What I was thinking is that probably there will be a list of emitters inside the system.
Be a list of emitters inside the system. Okay.
Because something's got to simulate them, right? Or you're saying let's just write it out in the particle toy code.
Yeah. Let's do it and see what
I
comes
concur.
Up. Yeah.
I concur. Okay.
I feel like we've occasionally pre-baked some interfaces that ended up being not the thing we wanted.
Okay. So instead, we're going to be adding stuff here, right?
Yeah.
How frequently do we want to spawn stuff?
Yeah. How did our old one measure this? Was it like particles per second or particles per frame? It's cool that we still have one. Particle rate, particles per second. Okay. Boy, it's nice that I put one comment in that file. Oh yeah, I remember the potential particle system. That was cool. I like that. Yeah, that was clever.
Okay. Yep.
Should we just, lift that entire thing? Or at least, yeah. Okay, because we had a duration, we had a time to live on the emitter itself as well, which was cool.
How many per second? 10?
10 per second? Sure. Let's do it.
Okay. And then, so potential particles plus equals our particle rate times. I'm just seeing simulation. I'm not worried about realistic, like frame rate independent stuff right now.
Totally.
We'll deal with that in a second. One of the things that I realized is going to be difficult about this, if we wanted to do frame rate independent simulation, where's the rotation simulation?
The Rodfell stuff, or
Our rotational velocity.
oh,
Wait, where do we actually calculate? We do update the rotation somewhere, right?
yeah. What is using DT here? Did we forget to
What the
use?
hell is spinning our things?
Did we forget to use DT? We might have. We might have just like added some numbers until it looked good.
We use DT. We use DT for the TTL.
Ah, great. Okay.
But oh yeah, so this is what I was going for. Like the rotational velocity here is nothing. Then we do the multiply here. This is where we compose it.
Cool,
Okay,
cool.
sorry. This is hard for me to see. But if we do want to make it frame rate independent, the rotational velocity needs to be scaled by dt. And that math doesn't actually make sense when represented as a quaternion. You can't just like multiply you can't just scale a quaternion by some value that's not 1 and get what you want.
Crud.
So instead you have to do a slurp, which is expensive. So representationally, one way that we could do this is actually we store the rotation as a axis and angle, which interestingly is the same amount of data. It is 3 numbers, which is your axis. It's basically a vector that just points in some direction, and your angle is the right-handed rotation around that particular vector. And then you could scale, if your rotational velocity was just like rotations around that axis, you can definitely scale the rotation value. But then when you convert that axis angle representation into a quaternion, or at least something that can be composed into the transform matrix, that requires a call to sine and a call to cosine. But it is something that we could push into the shader if we wanted to.
Right. Yeah. Interesting. And when we were reading about this, I did see a bunch of examples that were talking about doing the rotation as axis angle in the shader itself as well.
Yeah, it's like how to do partial quaternion rotation. Doing a partial multiplication, blah, blah, blah. How to get part of quaternion. Fractional. Yeah, so
yeah,
you got to do some shit, right? And what this actually does is it decomposes it into axis angle representation, gets a portion of the angle, and then recomposes it into quaternion, right?
Oh gosh. Okay.
So it raises the question of why don't you just store the axis angle representation as your base data in the first place?
Yeah, I'd be curious about that ending up on the GPU at some point, so we can see how that shows up.
Yeah. For now, I'm just gonna assume 60 FPS, full stop.
I think that's very fine.
Because that's what this is doing. It's basically saying that this rotational velocity is like rotation per 16.7 milliseconds.
Yeah.
Right. Okay. So we add to our potential particles, and then we say while potential particles is greater than or equal to 1. We chop one off, right? And we spawn a particle, right?
Yep.
And our TTL is going to be random, right? Say 1 to 3 seconds.
Sounds good.
And our rotation is going to be well, we're just shooting triangles, right? We just basically want some.
I say, do we just start with the identity quat for these?
Yeah, we can do identity.
Go from there. Our simulation has some interesting properties where, isn't it? Rodfell is like dependent on the index that we put in there right now, or did we change that?
Rodfowl is random right
Okay,
now.
yeah.
How did I choose this?
Oh, I see.
Rotation
Nice.
axis. Oh, I just picked a random rotation axis.
Cool.
So we can actually initialize them with random rotations, right?
Yeah. I was gonna say, we should just move this.
Oh, shit.
That's the code we want. And in fact, we're going to delete the other one that's adding the 10,000, right? Yeah.
Too true. Where was that?
Oop, right there. Yep. Const particles. Yeah. Oh, so
This whole thing.
Yeah.
Okay. Now we want them to appear maybe a little bit closer to the origin.
Yep.
And then the time to live for these particles, just 1 to 3. It's be faster.
Cool.
That's pretty neat, right?
Mm-hmm. That sure looks like a particle emitter to me.
It sure does. Okay, so now maybe we want to give them some motion, shouldn't we?
That was gonna be the next question. Yeah. Do they need like a vector, direction vector?
I do.
Yeah.
All right.
It's time.
It's time. All right. So what we're gonna have is we're gonna have a private vel, which is a float 32 array, which is 1 vec3 per particle. Should these be plural? Everything else is plural.
I think so. Yeah. Except for active, maybe. I don't know why that doesn't need to be plural.
Active is a adjective.
There you go. Yeah. But like I've seen actives as a set, but it doesn't sound right here. No, don't do it. Don't do it. Please.
Move your hand away from the this dot vels. You float through the array of 3 times our capacity, right? And the way we simulate velocity is we do a transformation of the position if. So basically what we want here is our rotation transformation that occur here, and then const vel equals.
Wait, you just put the rotation transformation in the.
Oh.
Oh yeah.
How do I do this in a way that's a little bit more coherent? This is probably what I mean.
Yeah, I think that's good. Ugh. The cows.
Now it's just cruel. But I think this is better, right? This is like we're saying like if it's not the identity quaternion, then apply a transform, right? And then we probably want to do something similar with velocity, right? Okay, and how many vec3s do we need? Do we need 2 temp vec3s? I think we need 2.
I think we need 2. I like this temp vec3 and temp quad solution, by the way. I think this came out really good.
I'm using tuples here so that so the type checker can tell us if we're indexing past the end of it.
Nice.
Alias are temporary. Position.
Yeah.
We'll see. We'll see what we need.
I think we need to. I think we need to allocate those two, right?
We do.
Yeah. Bless this type checker.
Yes. Okay, those aren't used. Okay. It's not super ballistic right now because we don't have an acceleration, but whatever. So our velocity is going to be this dot vels of. I have a notion of an index 4. I'm going to make an index 3.
Oh yeah, I noticed that elsewhere too. I like that.
We'll see. I just added it in today, and I was kind of like, do I like this? Maybe I do. Maybe I don't. I don't know.
And what? Why are we assigning these manually instead of we can't just copy? Oh, because the vels is a byte array. Yep.
Yeah.
Never mind.
This isn't that much code. I don't mind.
No,
this is
no,
the fastest possible way to do it,
Yeah,
I think.
absolutely.
Although I agree with you that it is not very pretty.
Yeah.
This is a good reason to use like C or Rust, right? Because this would be one equality, right?
Oh yeah.
Apply ballistic motion, and then the position is this one. We can do a copy, right? So we do what is it? This dot translations. Copy from or copy into. Pause. The offset is index 3. The length is 3.
Yep. And then pause.
And this is as a float 32 array, right?
Yeah.
And now, vec3 dots add, right? Of our, and we're going to add into our pause, our velocity,
Yep.
right?
And copy from.
And then, yep. And the offset is index 3.
And then another as float 32 on that.
Bummer.
Sweet.
So
now if we give it a velocity, is it just going to work?
Yeah, let's check it out.
I think it is. Oh, we need to make it a config option, yeah. Sweet.
That doesn't look right.
So we're not setting it, and is that totally busting us up here? Or rather...
You're right.
Well, I do want to live in a world where we don't have to set it. Maybe. Maybe not.
Vec3 dot create or from values, and just like we're gonna lerp. It's gonna be like kind of random lerp from 0.5 to 1.5. Math.random. We'll see how that goes.
Sweet. Well, that's unexpected.
They're kind of flickering in and out. They're too fast.
Put some zeros in front of that, yeah.
They also stopped rotating. Still too fast.
They're rotating. They're just going real fast. Now,
this should be actually maybe negative as well because we want maybe want to go in a sphere. What if we did this?
Oh, right. Yep. Cool.
That's getting there. They kind of don't start at the origin though, right?
I mean, through no fault of their own.
Yeah. What if we did like?
Yeah, like really, really close to that. I like that.
Yeah. This is zoomed out.
Yeah, dude, that's sick.
It's getting there, right?
That velocity feels. I say the velocity is. Whoa, yeah.
The velocity feels yes.
Fast. Is that the distance it moves per frame or per second? I guess
it is per frame.
Okay.
So we should scale velocity. We can. I mean, velocity scaling is easy.
Yeah.
Right. Like what we can do here is the velocity can be multiplied by dt, right?
Yep, totally.
And now it's just going to be like really slow.
Fuck yeah, it is.
But now we can maybe take it up an order of magnitude, right?
Mm-hmm. Cool. It's full of stars. That looks sick.
It's pretty cool.
Yeah.
I almost want these to be faster.
I think so. That was slower.
Ah, shit. This is what I meant to do. Oh, it's not a real number. Nope. How did it get the negative in there?
Huh. I don't know. I mean, that was pretty cool too.
All right, this is a fun confetti parade.
Yeah.
Yeah.
Well, this is great. I like that we can sort of pick our arc with that initial vector as well. So that's cool.
Yeah. I can imagine an emitter picking the rotational velocity based on the angular, like which direction.
Like how, going. Yeah.
Do you know what I'm saying?
Mm-hmm. Like a higher or lower velocity closer to like the center of the arc that it's trying to emit on. Right. Yeah. Yeah.
That looks you know what else cool. Turns out to be a surprisingly difficult problem?
What's that? Oh no.
Yeah, so apparently when you just do random spherical coordinates,
okay,
everything kind of clusters at the poles.
What? Shit. Okay.
But we're not doing spherical coordinates here. We're doing random XYZ coordinates.
Hmm.
And I don't know how that maps onto spherical coordinates and whether or not you get equal distribution on the surface of a sphere.
Right, because we want, like, if we were going to do, I mean, we've got explosion right now. If we were going to do muzzle flash where it was like a cone starting from a point.
Yeah. Yeah, how would we do a cone?
Yeah.
We'd have different emitter logic, right? This is the dumbest possible emitter, right?
Yeah. But I really like that the system is just running and actually this logic gets encapsulated at the emitter creation because that feels right to me.
All right, so let's do something super cool then. Well,
what are we doing?
We're gonna do acceleration.
Oh hell yeah!
Did I spell something wrong? Somehow particle, like I'm looking at this word now and it's
I
ceased meaning anything. You know?
Wait,
It's like, does it have...
what is the word for when that happens? Because it happens to me almost every stream with this game for whatever word we're
Word
staring
for the thing where a word stops losing meaning after you repeat it.
Wait, I saw instead of losing, if you said stops looking. Oh,
Semantic satiation.
wow. There's the stream title.
Oh,
Just a great word.
yeah.
I'm just gonna
Good call.
Start my note docs. Hey, this is session 80, by the way.
Oh, shit. Are we at a year?
Ooh. Yeah, pop back over to that YouTube and let's see where we're
Your
at.
channel. Let's see. Starting from scratch, April 15. I don't know how long it took us to convert this into a video.
Well, is that the upload date or is that the recording date? Because it might have been the recording date.
You know, for these earlier videos, I was very diligent about setting the recording date correctly.
I think that's why. Yeah, hit edit. I bet that's set as the recording date. Oh, please don't report our video. What happens if you self-report? Or are they just like, great, you told us?
Oh, I don't know. I stopped setting the publication date because the widget doesn't work. Have you tried using it and it like doesn't include today's date as one of the options?
I always set the recording date to the actual date. Does it not? Is what I'm doing not showing up on our channel?
That's a good question. I don't know. I stopped doing it because the thing didn't work.
That's fair. I'm gonna go look at my videos and see what it did.
Recording date April 14. So I did happen to set it for this one. So we're getting close to a year.
Getting close to a year. I like it.
We're gonna have to figure out something fun to do for the 1 year.
Damn.
Like adding more dogs.
Shit, April 15th. That's the day that we can get vaccines.
Oh my god. So that's what we can do is just go get vaccines.
Isn't that fucking weird? Yeah.
It's gonna be a shit show.
It's gonna be a huge shit show. I have a script that checks CVS's in California for me.
Yeah, gonna get some of that J&J right in the arm.
I'll take whatever. Yeah.
Yeah, I'll take whatever right now.
Yeah, I'll come back for seconds later.
Yeah. Those poor AstraZeneca bastards.
Yeah,
That's been the like.
I don't understand. What
from
happened?
like the very beginning, like their whole, they were the ones that had the mistake in the trial results, right? Because they like gave a partial dosage to people, right?
Is that what it was?
This was the same. Yeah. They it's been a very fraught thing, and then like I think they've run into trouble with multiple governments. I wonder if the CEO is just unlikable. And so therefore everyone's just kind of like not giving them the benefit of the doubt, whereas other companies would.
That's really funny. I'd buy that. Didn't they? I thought they had something where someone had like serious side effects, but it was like actually an unremarkable number.
So that is the most recent thing with that vaccine is that it got put on hold. The rollout got put on hold in I think Italy and in
the UK
and in Germany.
Germany, okay.
I think it was rolled out. That's actually the main one that's being rolled out in the UK. It's the AstraZeneca because Oxford was working on that trial.
Oh, fascinating. Okay.
Yeah, and apparently the UK didn't have issues, but blood clots was apparently the side effect that they were worried about.
So, blood clots were the side effect, but at a like order of magnitude lower than blood clots from birth control. Like it was actually like still unremarkable, even with how many blood clots they found, which was really too bad.
Yeah. So it didn't even. So maybe the complaint, maybe the thing is that it's like what's your control, right? Like
yeah.
Like
I saw it and I was like, that sounds medically not interesting to me. If it's like as good as a rare side effect of like other meds, so
right.
Give me the vaccine. But yeah, don't we have like 100 million of them just sitting at an airport or something? Just
yeah,
chilling,
right.
Literally.
There was a whole thing about like requiring Biden to like asking Biden to like release them because I think I don't know what the holdup is. but they made it sound like we had the ability in our executive branch to just like let people
Like
do
send
something
them
with it.
to the global south where there are not enough vaccines. Like send the vaccines literally anywhere.
Yeah, because they're not you're not allowed to um, you're not allowed to use them in the U.S. Or
Right.
did it just get approved? I don't remember.
Not here. Not yet.
Okay.
Yeah, so if they're not doing us any good, like send them to someone who's going to be like, these are fine, please. Like, yeah, it's silly. No, we just had a trial that went well, and then we have once again started questioning whether this company is real or not.
Oh.
Maybe like you just shouldn't piss off the people who have to approve your vaccine. I don't know.
Okay, so
All right.
we're gonna do this cool thing
Yeah, what you doing?
where,
I saw the third Vec 3 go in there.
yeah, what we're gonna do is we're gonna modify the velocities.
Cool. Oh, by acceleration. Yep.
Yeah. Or we're gonna do the simple and incorrect Euler integration, where we modify the velocity by the acceleration times dt.
Okay.
We need to actually get the acceleration.
Yep.
Modify the velocity. We write the velocity. The acceleration doesn't change. The acceleration is constant. And then why did I think pause is fine where it was. Okay, so we pull out the velocity, we pull out the acceleration, we update the velocity. We haven't, oh, and then we pull the translation out.
And add the new velocity to it. Okay.
Yeah. Okay, and then here's to cap it all off.
Gotta put it in here.
We are going to simulate a constant downward velocity, otherwise known as gravity.
I like it.
And it's our y that's going down, right? Let's do negative 0.05 and see how it goes from there.
Cool. So we're about to get like kind of a fountainy effect. Though, what happened?
Disappointing.
Yeah. So wait, yeah. If you comment out
This?
yeah, let's take out the ad real quick. I want to see those particles moving again.
Want to take out this?
Yeah. Yeah, what happened? How's that set?
No errors.
Oh, where we do this dot vels dot set. Huh, that should work.
This should just be writing it back into itself,
Yeah.
right?
You want to comment that out too?
This should fix it though, right? Yeah.
Okay. Weird. Val index 3.
Well, why don't I just do this the...
Alright, yeah. Line 225 needs to be 2. Shoot him at the screen.
This is a surprising outcome.
Yeah. So if you okay, wait. if you take out line 222 again.
Oh, I think I know what happened.
Okay.
Nope, I'm wrong. I thought I was like setting the wrong value when I was setting the acceleration, like overriding the velocity.
That would have been a good guess, yeah. If you take out line 222 again to no longer add the acceleration,
Hang on one second.
Dean says that you made them all whittle. You did.
Yeah.
They're,
Line 222.
Yeah. I just want to see that writing back into vels is for some reason fucking it up. What the hell?
Am I using the wrong? Oh, my temporaries must be. Well, no, this looks good. Should I be zeroing these? No, because we're just copying over them, right? Did I not create?
You created?
Well, I created another one.
Yeah, there's no TypeScript problems here. Why? And this .vels is a float 32 array.
It's a vec3. Yeah.
Sorry, the vels. Vels is a float 32 array. Yeah. Yep.
Mm-hmm.
That seems really reasonable.
Oh, I see. Because we're multiplying it by dt.
Oh.
It's not the right thing to multiply by.
Should we take the velocity, add the acceleration dt, store our velocity, and then add velocity times dt to the translation?
Yeah, that's right.
Okay.
Yeah. So what we want is we take the velocity.
We lose those dt's for the first 3 assignments. Yeah.
We take the velocity. We get the acceleration,
and that's okay. I think the delta.
Which theoretically, we could do something like. Okay, if that's fine, then we'll just leave this here.
I think so. Yeah.
And then we do vec3 dot add into vel of excel.
Yeah, line 224 was. Oh yeah, yeah. You just wrote the same thing again.
And then we copy it back in. Then we do vec3 dot scale into velocity of velocity by dt.
Yeah.
And that's it, right?
I think that's it. Cool.
The gravity's not quite strong enough.
I think yeah, I feel better about that now though. Cool.
We're getting a little bit of arc now, right?
Yeah. So if we what does it say for our initial velocity?
Let's make the y positive, shall we?
Yes, exactly. Yeah, line 112. Make that like 0 to 2 or something. Or 1 to...
Oh, yeah, 0.1, yeah. So it has at least a minimum amount of upwards velocity.
Oh, yeah. Cool. Cute. Basically just made a little particle fountain. No, I like it.
Yeah. I almost want this to be a little bit higher.
Yeah.
And then let's allow it to go up a little bit higher initially.
Mm-hmm.
Let's do 0.5 to
2 or
3 even.
Totally. Yeah, that looks cool. Party time.
Yeah, party time. Excellent.
No, damn it, they sold out. Hate it.
They sold out on you're talking about for the Super Bowl?
I'm so angry about Wayne's World.
For DoorDash, wasn't it?
I thought it was Uber Eats, which is somehow even worse.
Oh. And then also Dolly Parton as well, right?
Yeah. Something about Wayne's World though, where it's just like the entire shtick was about like fighting the man and like being the independent company that didn't fucking sell it to corporations. Shilling for a corporation is so weird.
Yeah. I remember, what's the name of the... I'm
old enough to care about Wayne's World, is what I learned.
You know the band Gang of Four, post-punk?
No. Are they great? I love post-punk.
They're amazing.
Okay.
They have an album called Entertainment. And then I think Natural's Not in It is the...
Natural's Not in It, yeah.
Is it, like... And like, these guys are like full-on situationists, like Marxists, right? Or at least they were back in the day.
Wait, is this a new band?
Oh no, this is like the
Oh, okay. Oh,
I
sorry.
want to say the early '80s.
There's a tribute album that just came out. I see. Where
Yeah,
where
it's
Tom
a you like.
Morello covers "Natural's Not In It." I want that.
Okay, yeah, yeah, but then they allowed the song to be on an Xbox commercial.
No,
And this song is about how entertainment seduces you into
fuck.
like it like entertainment is the opiate of the masses. And then they sold that to an Xbox commercial like I want to say 10 years ago. It was back when post-punk was like becoming a thing, right? Like because post-punk I want to say mid-aughts was like that was the style that everyone was kind of quoting.
Oh yeah.
Um and so I think they had an interview with the band. And they're like, "Yeah, we just kind of love the irony of it, you know."
Oh
And I was
fuck
like,
yeah. Okay,
"That's not
great.
the kind of irony you're supposed to love there." And it was like they tried to play the whole like, "Isn't it interesting what we're doing, subverting our own lyrics?" You know, like it was like they're trying to play the intellectual card,
Oh fuck.
and that is exactly what Wayne's World was doing as well.
I was gonna say yeah. They beepled all over it.
Yeah. Ooh.
That's
Oh well,
too bad.
let's enjoy our little fountain
I
here,
just
shall
say
we?
I'm gonna listen to this album because I'm sure it's fucking rad. So
Yeah.
whatever. Gang of Four. Yes.
Yeah.
I was really stoked that Pittsburgh had some vintage punk when I was there, and I loved it.
Yeah.
This fountain looks great.
So yeah, this fountain looks pretty sweet.
Hmm?
Do we want to modulate the colors a little bit? How do we do that?
Yeah, I was wondering about that. Like, should our color, like, if we wanted to make this sort of, we've got a fountain, it could be watery. Are the colors are just random right now? Should we like pick a blue and like lerp it a little to the left and right of the blue?
Yeah, we can. Oh yeah, that's great. Okay. Not much red, right?
Not much red. Yeah.
0 to 0.1.
Yeah.
Not much green.
Not much green.
0.2 to 0.5.
Okay.
And then blue, we want a lot of blue.
Yep.
0.6 to 1.
Sounds good. All right. Yeah, that looks great. Yeah. Is that what you're thinking in terms of modulating the colors, or
Yeah, yeah.
or were you thinking of turning the color down as it dies?
No, this. Oh, I mean, we could do that as well.
Yeah.
That is actually
That's pretty hard for what we've got right now, isn't it?
what we would want is a color velocity, or we would
Cool. Or like a final color to sort of move towards.
a final color that is lerped along. Yeah, exactly.
Yeah.
Or like a target color that is basically along the TTL.
TTL. Yep.
There's like infinite variations, but that level of logic would need to be baked into the particle system itself, right? Because
Yeah.
like,
But I'm okay with that. I mean, like if we want to go that route, that's a pretty cool configuration.
yeah, I want some more green in here. Sorry, this matters to me greatly.
No, I'm with you. Oh yeah, that was a good choice. All right, that's really cool. Yeah, and I feel like this is pretty good as a particle system. I'm curious if we were to log out the high water
High
mark.
watermark.
How,
I was thinking the exact
how
same
high is
thing.
our high water mark?
Yeah.
Is that why we made a blue particle fountain? Because we said the word high water mark like an hour ago, and we're like, oh yeah, okay, we're doing water today.
Is this one? That's one of those things where like
Semantic satiation. No.
where you show people a bunch of unrelated images and you're like name a vegetable, and everyone always says carrot.
What? Why? The fuck?
Why does everyone always say carrot? Yeah. Explain to me like I'm 5. What is 1 plus 1, 2 plus 2, 4 plus 4, 8 plus 8, and then ask to think of a vegetable. Why do most people say carrot?
Yeah. Why? Fuck.
This seems like the most likely explanation. It doesn't matter how you seed the exercise, People just say carrot anyways.
I buy that. Is it in fact that what you're doing is resetting the brain to sort of go back to a basic? Yeah, there it is. Oh, it's the second comment. Empty the mind. Great.
So there's more than just this. I think there's also like name a color. Like there's certain things that like are just canonical in terms of like we have like the one example of a particular category.
Now, this makes me wonder about like isn't this like the trick that mentalists do where it's like somehow they seed you into saying exactly what they want you to do?
Mm-hmm.
And that I don't understand at all.
Back when I was still working for Chain in our first Vegas trip, which was legendary.
So I hear.
Yeah, it was legendary. We hired like a famous mentalist pickpocket sleight of hand guy to come, and it was like it was definitely an Adam Ludwin special there.
Is this the guy who stole Bob's sock?
It probably was.
Yeah. Okay.
Yes. It was the guy who had been in a New Yorker article.
All right, that's pretty cool.
New Yorker article about sleight of hand guy. Is it Ricky J?
Did you get Ricky J do your thing? I've heard of this guy before.
No, is it Ricky J? No.
Oh yeah, because I think he's
Well,
dead.
maybe this guy. Yes, it was this dude,
What?
Apollo Robbins.
What?
Yeah, he was great.
Damn. Yeah, I want professional pickpockets to come to my party, but I missed that party.
Yeah, we were all sitting at a steak restaurant, and then he came over and like just talked to us for a couple hours and showed us tricks. And what was cool about it is he also just like explained what he was doing.
Ah, that's really
And
cool.
he got into a little bit of the psychology of it.
Well, the best part is
These
like,
people terrify me though. Like they're really good at like poking at your weaknesses
as I
as a
say,
human being.
if someone can tell you how the trick is done, they're too fucking good at it because they're so happy to tell you because you'll never even see it, and I love that.
Speaking of people that are good at poking you in ways that you don't like being vulnerable, I think that's salespeople as well, right? Like I just went to the, I just went to, test drive some cars today, and that's always an incredibly uncomfortable experience. Just because there's like a lot of money involved, and you know that people are like trying to manipulate you, but at the same time, that thing in your brain that wants other people to like you is also being engaged at the same time.
Right, you want to believe that there's some truth in there. Wait, by the way, sorry, can you unclose those tabs? The next one. I just want to point out that you searched Apollo Robbins and Google was like, by the way, here's your last search right next to the search you just made. Related to. Just creepy. Yeah. That's all.
I use DuckDuckGo and Firefox for most of my personal stuff. I'm just using Chrome right now because it's a fast browser.
What is DuckDuckGo? Does it just stop Google?
Oh, DuckDuckGo. I'm sorry.
Oh, DuckDuckGo. Yeah. Sorry.
Yeah, you know this.
I'm familiar. DrGo would be a new one for me.
DrGo.
DuckDuckGo is the place to be.
Yeah, it is actually apparently it's just Bing under the hood.
Mm-hmm.
They pay Bing a bunch of money and then they strip out the ads, which that's fine.
That's fine. Strip out the ads and don't associate my data with me. That's great.
Yeah. Look at our cool water, man.
It's fucking rad. Should we try to make multiple emitters?
Yeah, we can totally do that.
Yeah. Is it time to extract this class maybe?
Yeah, I think you might be right. So how do we do that? Does the emitter... Do we want to run our own emitters? Should we keep the emitters outside of the system entirely? Something's going to have to memory manage them because the emitter itself might have a lifetime, right?
That is a great question.
See, we could sit the emitters inside of the particle system.
I like the.
But it's weird because they don't really need to do anything in there. It's just that having a particle system gives you one update function to call, and it would handle the lifetime of not only the particles but also the lifetime of the emitter if the emitter has one.
Yeah, I was gonna say I'm not sure what the emitter life cycle looks like yet because right now I kind of like the notion that any class at all can just add a
Can just
particle.
add particles. I agree with you.
Yeah, it's kind of nice.
Yeah. I'm gonna turn up the acceleration a little bit. Sorry, I'm looking at it out of the corner of my eye. I'm like,
You're like, that water is really, really going
needs to
pretty
be a
high.
little stronger.
Yep, I'm with you. Gravity's hard, man.
That's better.
That's very neat. I feel like if you made less,
Should the TTLs just be constant?
should the TTLs be constant? Oh, sure. I mean, we get to play with this as much as we want. I guess I was kind of thinking it'd be really nice if every emitter was actually just like we had the muzzle flash emitter.ts and explosion emitter.ts that like just have all this in a class doing whatever functions they need to do.
And
like,
you just pass in the particle system.
Yeah.
Or even an add function.
yeah, and just like something we'll have to have an interface for like figuring out how to deallocate them basically, but like it'd be really nice. It'd be super easy.
An emitter manager, something like that.
Yeah, and I feel like the amount of configuration going on here is just like it's enough. Yeah, it's enough that like for anything complex, I want to have some method for creation, and that's like that'll be enough to look at.
Okay.
All right, this is pretty cool.
So if we were to factor this out, let's just do it.
Yep.
Let's just call it the water emitter, right? Or just call it the emitter.
Yeah. Oh man, we're gonna put some fountains in this game.
And all it really does is just collect some of our variables that we had down here, right?
Mm-hmm.
And the particle rate doesn't even need to be configurable, right?
Yep. Correct.
And this is going to need a system.
Yeah, a system or add function or whatever, yeah.
Yeah. For now, I'm going to do this.
I think that's great because it's got the public method on it, right? That's easy.
Yeah. But it kind of doesn't need all the rest of the stuff. JavaScript is so powerful that we could just pass in the closure and has a nice kind of, but you know.
We know that we'll do it later.
Yep. And then we're going to just yank all this stuff.
Mm-hmm. Wowza.
I didn't like it.
Let's see. There's a couple things not to like, I think. The constructor, we've got some non-types out at that level. We do need potential particles, don't we?
It's this one that we don't want.
Yeah. And then we have to assign system. We're not using it yet.
And we need to actually instantiate this thing.
Uh-huh. Uh-huh. Yeah, the word particles is just meaningless to me now.
We're semantically satiated.
Semantically satiate. Wow, shit. Cool. Great.
Yeah.
Should we do like 3 of them? So I guess now the emitter should have an origin, and then we can actually move them around.
Good call. Yep.
Totally unrelated, but did you see that Subnautica is free on PS5 or on PS4 for the next month? Yeah.
Is that a good game?
It was one of my top ones of the year. It's a terrifying game.
Oh, I'm sorry, I forgot about that.
Yeah. No, it's the one that has the horrible sea creatures in it.
Oh yes, I remember that
Yeah.
now.
Yeah, no, I think you blocked it out of your memory because it was truly horrific.
That's probably what happened. Very likely.
Yeah. It checks
Okay,
out. I would have done
so we
that
want to
too.
have a couple emitters, right?
Yeah.
Let's do 1.0, 0.0, 0.0.
From values, yeah. Yeah. Do we want? Why do we want Z? I mean, I guess it can go in the air. Great, we got 3 of them. Whatever. Nice. What's the grumpy about?
I probably made a programming. Oh no. It's a little bit hard to see the separation, right?
Yeah. Yeah, we could either make them tighter, we could move them apart. We could do a little both.
Maybe let's move them along the x-axis, right?
Oh
Let's
yeah.
do
Do a little
-5, 0, and then 5.
sounds good to me.
Let's keep these all zeros.
This is a little Vegas fountain-y kind of vibe. Oh,
Yeah.
-5. Ah, cool.
-5 is too much,
Yeah, it's
at least for our default zoom level. Yeah, this is our Bellagio water fountain.
Bellagio. That's the word I was looking for.
Yeah. And
Nice. All right, yeah. Let's log out that high watermark. We forgot. So what is our? We're doing 100 particles a second, with TTLs of 3 seconds.
yeah, so
3
this should
emitters.
never.
Should never go over 900.
Yeah, let's see if it gets over 1,000.
Yeah.
Not super visible.
No, that's great. Okay.
All right, this is what we want, right? It's kind of cooking
actually
it.
seems great. Yeah.
Yeah.
I'm wondering about those 5, but maybe that's the overlap of some being created on the same frame that some are destroyed. Basically, like there's a particle spawn and a particle death.
That's right. There's a little bit of floating point error going on here too, because the potential particles accumulate over. Like there's also a little bit of error that's accumulating.
Yeah,
right?
but like kind of intentionally, right?
Yeah, intentionally, exactly.
Yeah.
So maybe the system works as intended.
I think that works great.
Yeah.
Cool.
Very nice.
Whew. Hey, that's not a dated reference anymore. It's back.
Yeah.
Fresh for 2020.
It still feels dated to me. I'm kind of embarrassed by it.
No, you're good. You're good.
Why do you put up with me, Dom? This is
buddy, it's truly a treat.
yeah.
That's really cool. I like that a lot.
Yeah.
And this is great too, because our Bellagio emitter could actually choose to like fan the water back and forth if it was like going nuts.
That's exactly right.
Yeah, because
exactly right.
it's only on creation and not in the system. So that feels really good to me.
Yeah, and I think what I like about this thing is that like basically the particle system is what does all of the high volume shit.
Yep.
And we're probably only going to have like a few dozen emitters max on screen. And those can be like garbage collected and like nude and like those aren't super high volume. So if they have internal state, it's not a big deal. Mm-hmm. It does matter though that we have hundreds of thousands of these particles floating around on the screen, and we want to handle them all in an efficient way, which is why that's essentially what this update loop is doing, right?
Yeah, it's really rad, and it's nice too because this feels like if whatever we need to optimize, we can optimize like this one thing.
Yeah.
And be totally fine. I'm sure we could write a very expensive add function, but I'd be surprised.
So I guess what we need to do now is do this particle tool. And the particle tool, what it really will do is it'll have a drop down that chooses the particular emitter type. And maybe each emitter type is going to have particular sliders that it cares about.
Okay.
Right?
Yeah. By emitter type, you mean like whatever class we have baked in there?
When I say emitter type, I mean like this emitter here is
that type, yeah.
basically doing this particular behavior.
Oh, right, because what we're actually going to do is like whatever the behavior is, we can tweak some of its inputs, but actually each one might have its own configuration options as well for us to tweak. Yep.
That's right.
Cool.
Yeah. Because you can imagine that this emitter might become, it is stateful already, right? But it might have more state, like you're saying, like fanning back and forth or changing colors over time, or the emitter origin itself moving, right? You could attach this emitter origin to the end of a rocket, and that now you have a rocket ship, right?
Yeah, exactly.
So we could even have a little emitter at the out of the back of the tank for its like smoke. Or whatever.
Little dust trail
for the dash.
I like that.
Or the dog, rather.
Yeah, the dog wishes. There's no tanks, only dogs.
Yeah. But yeah, now we've got the. This is a couple dimensions more complicated than our other one, not just because it's in 3D.
No, it's really great, and it does a lot more.
Yeah.
We've got triangle particles. Can we put the dog in here? Can we put the cube in here? Like, what is our particle system capacity right now? Does it have to be a triangle?
It doesn't have to be a triangle.
I guess it's sort of baked into the particle system right now, but I wonder if we want to have a.
Well, our shader does solid colors, but otherwise it should be able to handle a bigger mesh.
Yeah. I'm just asking this to 50% be a jerk, but also I'm a little curious.
Okay, so you just want to throw the dog in here and see what happens. Is that what you're saying?
Can we? Yeah. Or the tree, or a cube.
Okay, well, we do have a cube that's easy to get.
Yeah.
Well, where is our cube coming from?
Where's the triangle coming from? Yeah. What are we feeding into the vertex?
Well, I guess I'm trying to think of how the particle mesh works. I think that there's what assumptions are being made here. We've got which primitive it is. We've got attribute buffers.
I think whatever name we hand it should just.
We have vertices per instance, so this matters, right?
But does that come from make render mesh instanced? Oh, sorry, we're passing that in. I'm sorry. Yeah,
we pass it in, so
gotcha.
We can make render till I do it. So actually, I think that's a thing that we could maybe try next stream.
Yeah, totally.
It's not going to be a matter of 4 minutes.
No, I'm glad.
I do have a 4-minute project for us, though.
Oh, great. Yeah, I'm glad that was hard, because, that will be the next one.
I think eventually I think we're going to want quads rather than triangles.
It's kind of what I was getting. I was wondering, like, if we can throw any model at this yet, but I also think so.
And... well, if we keep triangles, I was going to say that we should try to move. Like I feel like their rotations are a little wonky, so I want to move them so that they're like the barycenter is the origin. Right now, it's not.
Yeah.
But if it's going to be quads, we don't have to worry about that. we can just make quads.
Fair enough.
But up to you. What do you want to do in the last 3 minutes?
Let's do that. I think that would look good. I think it would make this look better right now, and I'm gonna make some GIFs of it. So.
Okay. If we did quads. Okay. So I believe it's just particle choice.
Oh, I meant do the barycenter, but yeah, do quads.
Okay, the barycenter. Okay. So how do we do the barycenter? Well, where is our triangle being defined in the first place?
Yeah, I still have that question. We lost it. Particle system
knit render. This is where it is.
Cool.
Okay. Components per attribute.
Okay, great. We very clearly can't drop any model in here. Wonderful.
Yeah. So what this looks like currently. Yeah, this is definitely like this is the center of the triangle is like below the origin, right? It's like sitting.
Center triangles below the origin. Right.
Because. Yeah. We go below the y-axis by negative 0.5, but then the triangle gets fatter along the x-axis as it goes lower, right? So how do you center... what is the angle I mean, we could solve this with trigonometry, right? What is the angle? Like you have your angle from the barycenter of the triangle going up to the top point is essentially 0 degrees if you're rotating from the y-axis. So the question is, what is the angle when you're pointing to either the lower left or lower right points? If you're going to the barycenter, it's 2/3 of a circle. It's 1/3 of a circle, right? Which is
Circle. Yep. Yep.
which
Okay.
is
Yeah.
120 degrees.
Triangle
So 120 degrees is it's 30 degrees off of the x-axis, right?
Mm-hmm.
So what we want is whatever 0.5 basically like if we have a triangle, I'm going to try to draw this.
Uh-huh.
How come Mac doesn't have a paint program?
Isn't that weird?
This is going to be awful.
No, I like what you're doing. I'm digging it.
Okay. Like that. That's our triangle.
Okay.
Now pretend the angle here is 30 degrees.
The angle there's 30. Okay.
It's not.
No.
It's more like 60, but pretend that it's 30.
Mm-hmm.
And then the top side of this is 0. Like, what do we want? We want unit triangles. Is that right?
Yeah, we want like a equilateral triangle of one like height, I guess.
So this is 0.5.
Yeah.
Right. And this is 30 degrees here. So this is a 30, 60, 90 triangle, right?
Mm-hmm.
This is a little bit difficult because this is actually like this is the 60, 30, but we're pretending that the 60 is 30, right? And I believe 30, 60, 90. What is the geometric relationship again? I think this is 1, or this is the square root of 2. What are the ratios again? Okay.
Oh shit! Cool.
So the hypotenuse, which is opposite 90, is 2x. Let's just call it 2. Opposite the 30 degree is 1, and opposite the 60 degree is the square root of 3.
Okay.
Right?
Mm-hmm.
So if 0.5 is opposite the 60 degree, which is the one down here, then we need to know what this edge is here, which is opposite the 60 degree. Sorry, the 30 degree. So it is 1 divided by the square root of 3, right? Does that make sense?
Yeah. Whoa.
How do I do the square root in in Alfred? Does Alfred have square root?
Ooh, that is a thing, isn't it? Option V? No, it doesn't work, unfortunately.
1 divided by square root of 3. Come on, Google. Oh my god, it does it.
Nice.
I could have just done that in JavaScript, right? I can just totally do 1 divided by math.square root
Uh-huh.
of 3. And it would be the same thing here.
Mm-hmm.
But then the question is, what is this?
Right.
It is the length of this hypotenuse.
Mm-hmm.
That doesn't make sense. It can't be 2. It's 1.
It's 1, and we've nudged it down 0.5. So is it correct as it is? I think it might be. Once you got the square root of 3 in there.
Um,
Why is geometry the hardest part of this sometimes? Should have made these quads, huh?
no, we're close here.
Yeah.
We're just trying to remember what ninth grade was like here, right? It's also tough for the ASCII art. Is there anything I just like draw? How do I draw stuff with my mouse on the computer?
Miro? Miro might be it. How to center...
Not even signed in. Okay. So, let me try to draw what I'm talking about here.
Okay.
I like how this has become our obsession. Oh my god.
Triangles forever. Great.
Wait. Actually, let's actually use
A triangle?
a kind of.
They-
It's gonna be kind of like this.
Wait, Jeff, I bet there's a triangle shape in here. Just throwing that out there. Under the square, yeah. Yeah. Oh, thank goodness.
Oh, and if I hold shift, it'll make it equilateral.
Ah, see, this is great. Everything's coming up Millhouse.
Yeah. Then now how do I move stuff? Where's my grabber hand? Oh. Come on, Miro. Just use typical conventions. I don't think 30 degrees is was the right math. All right, the Barry Center is going to be kind of like this. Right? Sort of.
I think it. Sorry, point. Yeah, draw where you think it's going to be. I think it's lower.
It's lower.
It's
like.
I think it's lower. Yeah, exactly.
All right. Well, let me move it up a little bit, like this.
Yeah, I think because I just found what is the center of equilateral triangle, and it looks more like that.
Okay. So. This is kind of like what we just calculated.
Ah, I see. Yep.
And I claimed that this angle here was 30 degrees. Do you agree with that assessment?
I actually do. Yeah.
My logic is that this is 1/3 of a circle. This is also the same third of the circle, and this is also the same third of a circle. That's 120 degrees. And we're subtracting out this 90-degree angle.
Yep.
So that's 30 degrees right there, right? Now, if the side of this is 1, the whole thing here is 1, then that means this is 0.5,
Yes.
right? This is so not better than ASCII that I'm embarrassed. But ASCII art, I mean.
Well, this is more legible than the ASCII art.
Okay, so this is 0.5, right?
Yeah. So we've got our.
This is the one that's opposite the 60-degree angle. So I was wrong, actually. So
What did I say? Our x coordinates seem straightforward.
right. So what we're saying is that like square root of 3 times x equals 0.5. So x equals 0.5 divided by the square root of 3. So this should be 0.5. Or rather,
So 0.5 divided by the square root of 3 moves the two bottom points up, but I think the top point also.
but they should be negative, right? So they should be.
Yeah.
Yeah, because they're this
They're
is how
below-
far they are under
Yeah.
under here, right?
But I think that also makes the
The top one is the hypotenuse, right? It's the same thing as this,
Oh, yeah, it is. Totally. Okay.
which is just 1.
It's just 1.
Does that make sense?
So, wait, so then that point needs to be 1 minus 0.5 divided by the square root of 3 because it is more than 0.5. Yeah. Yeah.
Oh, you're right. You're
Yeah.
right. It's x. So our x is this. So this is actually 2 times x. So it's 2. It's 1 divided by the square root of 3.
Okay. Yeah.
Oh boy.
Yeah.
My
For that one. Yeah. And we're going to do this, and our rotations are just going to look pristine now. Are we?
I mean, we can't even really tell.
I know. I was going to say, are we doing...
They do actually look good.
They look a
I'm
little
gonna
better.
just I'm just trying to convince myself that they are, because everything should be rotating around the very center now.
I was going to say, the emitter is doing some scaling. Are we doing random scaling? Do we want to turn that off for a second so we just see equilateral triangles rotating correctly?
Okay.
Because I bet that'll be really satisfying.
We want to turn off scaling.
Yeah, or just scale everything to 1 in the emitter. Let's not change the system. Yeah. Do we scale in the emitter? I forget. Maybe not.
Let's see. We do scale randomly.
Oh, cool. Yeah.
You just want this to be ones?
Yeah, let's make it all ones. So we'll get like triangles that, or all the same number, like all point one or something. Because 1 is going to be quite large.
Kind of hard to tell with all the motion going on.
It is, but it looks. We could turn off. We could take it back to random positions and no velocity and no acceleration if you want to just see them doing their thing. We got the emitter controls everything. We can do it.
Oh yeah. So you're saying
zero velocity, yeah, and 0 acceleration. Well, that won't work. I wish. And then big old random positions, yeah. I mean, that looks... I think they're rotating correctly.
I think so too.
Yeah.
Before, an incorrect rotation is you're basically gonna get like a weird wobble on the triangles, right?
Yeah. Well, if you revert the mesh now, it should look a little weirder. Which I see what you're saying. I think we'll be able to see.
Yeah. Where do I put that particle system?
Man, I don't remember. Yeah, there it was. Down, yeah. Yeah, sorry, there was a method to my emitter madness.
Copy this.
Oh, they wobble like heck. Yeah, we got it right. Those don't look right. Nice.
Oh, some of them are just, I was like, why are these disappearing? And it's because...
They have a lifespan, yeah. We did the whole thing. It looks a lot better with our new stuff, so hell yeah.
Right. These are much more balanced rotations.
Mm-hmm.
Right. Okay. So let's walk it back. What did I do? What damage did I do?
Just undo it all. Yeah, it's fine. Thanks for humoring me.
No, I'm glad we did this. Is that it?
Yep.
Oh.
Sure is.
Gratifying. Yeah.
Hooray. That's really rad. So we can actually... I feel like it might be nice to have sort of some options in here where it's like the particles are triangles or squares or spheres or something, and we can run with that.
The Bellagio of game particle emitters.
Nice. Trying to go full fountain on this? I like it.
Yeah.
Pretty good.
All right.
Solid Bellagio.
Congratulations, Dom.
Thanks. Dean says if this doesn't go full Bellagio, I'm going to be disappointed. Man, let me tell you what I'm thinking about doing right now.
Because we can't make them do this, for
Yeah.
sure, right? Not only can we have them shoot in a circle, we can also have the origin point of the emitter also move in a circle.
Due to the 15-second delay, apparently he was typing go full Bellagio right as you said, we're going to make this go full Bellagio. What is laminar flow? I don't know what that means. Laminar flow. Oh, boy, we're going to have to make a fluid system, aren't we? Shit. Oh boy. All right. Yeah.
I'm adding more emitters.
Yeah, do it. More emitters. Just all over the place. It's only 300 at a time. We can handle like lots of these.
We can handle lots of them.
That looks so great.
All right. Good work, Tom. We did it.
Good work, Jeff. Yeah, hell yeah. Oh, nice to get back into it. I always feel a little rusty even when we take a short break, so hell yeah. I'm going to try to make some Bellagio things now, I'm not going to lie.
Okay, yeah. I mean, I think the particle emitters are your specialty, so I think...
Yeah, they were the first time, and then we changed to 3D.
Damn it.
So now we got to go to 4D.
At some point, we're going to stop slide tackling ourselves with technology, and we're going to actually make a game. But for now, look at this.
Yeah, give it some time. This is still great.
Yeah, we'll give it some time.
Fuck yeah. All right, cool. Well, I'm going to hit stop on the Twitch. Thanks for hanging out, Dean. Have a good night.
Take care, everybody.